Good afternoon. Tips for workshop questions, homework 3. Let's look at B1. Stationary points are asked for 3 functions. One, it's a quadratic function. So step 1 is to write down the FOCs. So the f dx is 4x plus y plus z is 0. That's number A. The f dy is x plus 8y is 0. Oops, what am I doing? X plus 8y is 0. It's B. So fz is x plus 2z is 0. C, this is y is minus x over 8. Z is minus x over 2 into A yields x, y, z is the origin. For linear k, for a quadratic function, that's expected anyway. So now that's the FOCs. Now we need to get the Hessian. fxz, fxy, fyy, fz, fz, fxz, fyz, fxz, fyz, fzz. Looking from here, it's 4, 1, 1. That looks like 1, 8, 0, 1, 0, 2. Determinant of H is LPM 3 is 4 times 8 is 32, 64, 64 minus 8 minus 2, 54 is bigger than 0. LPM 2 is 32 minus 1 is 31, it's bigger than 0. LPM 1 is 4, is bigger than 0. It's positive definite, a minimum. 2. Again, we do write down the FOCs. So the f dx is minus 3x squared plus 3z. That's it. Minus 3x plus 3z. So that's minus 3x squared minus z is 0. It's A. The f dy is, what's the f dy? 2 minus 2y. 2 minus 2y is 2. 1 minus y, b, so y is 1. The f dz is 0, of course. 3x minus 6z. 3x minus 6z is 3x minus 2z. So Z is 0, C, so Z is x over 2 into 1 into A, C into A gives us x squared minus what Z is x over 2 is 0, so x is 0 or x is half, y is 1, z is 0, z is half, let's do that. So 0, 1, 0 and half, 1 half. What am I saying? Quarter, 1 quarter, 1 quarter are the stationary points. Now we need the Hessian. So the Hessian is fxx, so it's minus 6x. fxy, that's 0, and then 3, 0, 3. Fy is minus 2, 0. Fyz is 0, and this is minus 6. So that means that LPM 3 is minus 72x, 0 minus 2 is 9, 18 plus 18 is 18, 1, 4 times 8 is 32 minus 4x. LPM 2 is 12x by the look of it, and LPM 1 is minus 6x. Oops. So for 0, 1, 0, we get LPM 3 is 18 is bigger than 0, LPM 2 is 0, LPM 1 is 0. So it's determinate, so that's indefinite. A bit horrendous, but I'm going to put it here. So for stationary point 0, 1, so the other one is half. For the other one, it's a half, 1 quarter. We get what do we get? Half minus 4 times half. Well, LPM 3 is less than 0. Minus 4 times half. Yes. Half LPM 2 is bigger than 0, and LPM 1 is less than 0. So that means negative ND. And so that means that we have a maximum. maximum. So 3 fx, we do the FOCs. Fx is 12x plus 6xy is 6x 2 minus y is 0. That's a. And y is 3x squared minus 3y squared is 3x squared minus y squared is 0. B. So from B we get x is plus or minus y. So y is x gives us in A 6x 2 minus x is 0, so x is 0 or x is 2, y is minus x gives us 6x 2 plus x is 0, so x is 0, which you already had, and x is minus 2. So we have 0, 0, stationary points, 0, 0, what is it? 2, 2, and minus 2, 2. Oh, I'm doing something wrong. Oops. I do this wrong. I started 4 forward, right? 12x to the third, yes. Oh, that was stupid. 6x, so that's 2. Plus 6xy, 3x cubed, so that's 2x squared. So it's 2x squared, 2x squared, but that's incorrect. Ah, come on. Y is x, so that's 6x to x squared minus x is 6x squared 2x minus 1 is 0, so that's x is 0 and x is half. This gives us 6x to x squared plus x is 6x squared to x plus 1 is 0, so x is 0, x is minus half, so stationary points 0, 0, looks like half, half, and minus half, half. Okay, let's see too. We'll let, oh, here, okay, what does it say? Goes double, right? That's right, that's right. This is this, this is this, so make another error. So x is minus half, so it's minus half, plus half, minus half. Yes, that's it. So that's 3 points. So we now need the Hessian. Hessian is what is it? 36x squared 6x. Proper squared here. 6x, that stays the same, and this is minus 6y. So this is 6 times 6x squared x minus y. So that h over 6, which that h over 6 is minus 6yx squared minus x squared is minus x squared 6x, so that is minus x squared 6y plus 1. Oh no, hey, it's sluggish today. This is incorrect. 36x squared plus 6y. Hey, that's 6. So it's 6x squared plus y plus x minus y. Then this changes to 6 minus 6x squared y minus y squared minus x squared. And LPM 1 is LPM 1 divided by 6 is 6x squared plus y. So now for 0, 0, the whole thing is, everything is 0, so that's id. So minus half, that gives us minus half, that gives us LPM minus half, that gives us LPM 1 is bigger than 0, and LPM right bigger than 0, LPM 3. Let's see. I'm still doing something wrong. It's minus half, as plus half. X is minus half, so y is minus half, so it's minus half. Here x is half, yes, y is, x is half, y is minus half. Yes, that's correct. So minus half gives us a minus half LPM 1. LPM 3 is minus a quarter plus 6, so that's bigger than 0, yes. And then this one gives us half minus half. LPM 1 is bigger than 0. LPM 3 is same, bigger than 0. So this is PD, and it's the minimum for both ones. B2 A quadratic form, so A is minus 1, 5, 5. We need to find the determinant. Lambda is 4 is 0. So lambda is 4 and lambda is minus 6. And do lambda is 4. Minus 1 minus 4, so it's minus 5, 5, 5 minus 1 times eigenvector xy is 0, 0. So xy is 1, 1 over square root of 2. Lambda is minus 6. It's 5, 5, 5, 5 times xy 0, 0. So xy is 1 minus 1 over square root of 2. So this is ID. So LPM2 is 1 minus 25 is less than 0. LPM1 is LPM. Come on. Come on. These pins. LPM1 is minus 1 is less than 0, so this is ID. And now we have these two eigenvectors, so then the new coordinates x1 tilde is 1, 1 square root of 2 times x, y, t is x plus y whole square root of 2, y tilde is not 1, come on, y tilde is 1 minus 1 whole square root of 2, square root of 2, x, y, t is x minus y whole square root of 2. So q is then q x tilde y tilde is then lambda 1, so that's 4 x plus y whole square root of 2 squared minus 6 x minus y over square root of 2 squared, and this is q. Check. So b, we write down b2 b2 a b, we write down a is minus 5 minus 5 minus 13 minus 10, 8 splits over as 4, 2 splits over as 1, 18 splits is 9, 9. So first we need to calculate this determinant. So that's minus 5 minus lambda, 4, 1, 4, 1, minus 13 minus lambda, 9, 9, 9, minus 10 minus lambda. So that's a whole thing, but you find actually that it's minus lambda cubed, minus 28 lambda squared, minus 147 lambda is lambda minus lambda, lambda squared plus 28, lambda plus 147 is minus lambda, lambda plus 7, lambda plus 21. Bit of calculation. Anyway, the eigenvalues are 0, lambda is minus 7, lambda is minus 21. So that's NSD. So that means that LPM 3 is bigger than less than 0. LPM 2 is bigger than 0, which is easily seen. LPM 1, which is also is minus LPM 3 is actually 0, which because there is no constant here, so you've already calculated that. LPM 2 is easy to see, there's 65 minus 16, so that's bigger than 0. And LPM 1 is minus 5. And now you need to calculate the PM. So PM 1's less than 0, PM 2's are all bigger than 0. So it's minus 13 times 10, so it's 130 minus 81 is bigger than 0, and then we have the top block, and then we have 5 minus 5 times minus 10, that's 50, minus 149 is also bigger than 0, so indeed that's correct. So given the eigenvalues, you now have to, so given the 3 eigenvalues, you now have to set up the systems to solve. That's minus 13, 919 minus 10 times u1, u2, u3 is 0 factor. Well, this you have to solve, but the solution which you have to find is 1 over solution, let's call this 1 is 1 over 3, 1, 1, 1, which you can easily spot, but otherwise solve the system. I leave that to you. Lambda 2 is -7. Then we get -5 minus -7, so that's 2, 4, 1, 4 minus 30 minus -7 is -6, 9, 1, 9 minus 10 minus 7 minus 10 minus -7 is -3. U1, U2, U3 is 0 factor. That gives us U2. Oh, come on. Why is it doing that? Turns out it's 1/14. So you have to do this yourself. I'm not going to do that. 1, 2. We can easily check that. -6, that's correct. -12, -6, -12. Yeah, that's correct. That's correct. But you have to calculate that step by step. -21. That gives us -5 minus 21, 16, 4, 1, 4 minus 13, minus 13, 21 is 8, 1, 9, minus 10 is that's 11, U1, U2. So you have to solve this as a linear system. I'm just giving the results. That's 1/square root of 14, 1 minus 5, 4, 16, 20, yes, 4, no, wait, that's 4, 9, this is 9, yes, it's 9, so 9 is 4, yes, 36, that's right, 1, 44, yes, and now, now you have to write down this matrix. So you just fill that with the eigenvectors as columns. Or did I? I did it actually incorrect. So this is 1 plus 25 plus 16 is 42. This 1/square root of 42. Minus 5/square root of 42. 4/square root of 42. Then x1 tilde is the first eigenvector as times x1, x2, x3 t. x2 tilde is the second eigenvector transpose with in the product with x1, x2, x3 t. x3 is u3 transpose in the product with x1, x2, x3 transpose. You get something, and now you have to check that x1 tilde, x2 tilde, x3 tilde is lambda 1 x1 tilde squared plus lambda 2 x2 tilde squared plus lambda 3 x3 tilde squared is q, the original q, x1, x2, x3. What am I doing now? Insert page. 1, 2, no, 1. So we'll go to B3. A railway company sells tickets. First class, economy class price is P1 and P2. You can sell Q1 is 210 minus P1 first class seats, Q2 90 minus P2. Economy class cost company is debt. So we have to write down this A, we write down the profit, Q1, Q2. revenue minus the cost, and the revenue is P1 Q1 plus P2 Q2, and the cost is 6,000 plus Q1 squared plus Q1 Q2 plus Q2 squared. So this then, if we fill that in with the P1, with the so given that Q1 is this, we find that P1 is 210 minus Q1. If we want to express everything, Q2 is 90 minus P2. P2 is 90 minus Q2. So then this is 210 minus Q1. Q1 plus 90 minus Q2. Q2 minus 6,000 plus Q1 squared plus Q1 Q2 plus Q2 squared. So you see where there's a prof. We need to find the stationary values. So that means we need to find pi Q1, so that's the pi dQ1. So that's 210 minus 2Q1 squared minus 2Q1 squared, so it's 4Q1 Q1, and then it's minus Q2, 0, call that 1, and now pi Q2 is the pi dQ2 is 90 minus 4Q2 minus Q1, 0, that's 2, and you need to solve this. So this one, oops, why is it now? Why is it doing that now? So this gives us Q1 is 90 minus 4Q2. I'm not sure if it's handy, but we can put that in 1. So that's 210 minus 4 times 90 minus 360 plus what is it? 16Q2 minus Q2 is is 0, so that's 15Q2. 15Q2 is, looks like 150, so that means that Q2 is 10, and then Q1 is 90 minus 40 is 50. So Q1 star comma Q2 star is 10 comma 50. That means that P1 star comma P2 star is 210 minus 10. 210 minus 50 is 160, and then 90 minus 10 is 80. I'll leave you to calculate. Profit, so P Q1 star comma Q2 star is, you have to fill that out. Now we need to calculate the Hessian. Let's see, we can put a hash in here, so that's the twice derivative, so that's minus 4 minus 1 minus 1 minus 4, so LPM 1 is negative, LPM 2 is 16 minus 1 is 16 is 15, is bigger than 0, so this is negative definite, so this is a maximum. Let's see what. Yeah, so the difference is B3 same B3B same as B3A, but now express all in terms of P1, P2. So you have the profit, as if profit, and there is a K there, but P, so you express this as R P1, P2 minus C. So you need to express this as P1, P2 by basically by using those two relationships to express Q1, or Q1 is already expressed in B2, etc. Same. Let's finish it for today.